This question says, an Arctic weather balloon is filled with 18.6 liters of helium gas inside a prep shed. The temperature inside the shed is 8 degrees Celsius. The balloon is then taken outside where the temperature is minus 30 degrees Celsius. Calculate the new volume of the balloon. So if we look at the ideal gas law equation, PV equals nRT, where P is the pressure, V is the volume, N is the amount or number of moles, R is the constant, and T is the temperature in Kelvin. What we notice is that volume and temperature are on opposite sides of the equation. Things that are on opposite sides of the equation are directly proportional to each other. So as the temperature goes up, the volume goes up, or as the temperature goes down, in this case, the volume should go down. To write this mathematically, we can write this as V1 over T1 equals V2 over T2. And this is called Charles' law. So, in order to use this, we have to put the temperatures in Kelvin. You can't put the temperatures in Celsius. So to do that, we add 273. So if we take 8 plus 273, we get the initial temperature of this balloon is 281 K. And then if we take minus 30 plus 273, we get the final temperature of this balloon is 243 K. Plugging in the initial volume of the balloon, V1 is 18.6 liters, divided by T1, 281 K, the temperature inside the shed in Kelvin, equals the new volume, we don't know the new volume, times the new temperature when we take it outside, which is minus 30 degrees C, or 243 K. It's very important that the temperatures are in Kelvin. To solve this, cross-multiply, so this times this, 281 times V2, and then divide. So you're going to take 18.6 times 243, and then divide by 281. Multiply these two, divide by this one, and when you do all that math, what you find is that V2, the final volume, is, to three significant figures, 16.1 liters. So you can either remember Charles' law or remember that things on opposite sides of the equation are directly proportional to each other, and this is how we write a direct proportionality. Note that in this case, the pressure on the balloon, atmospheric pressure, is constant, and also the amount of gas in the balloon is constant. You can only use Charles' law if two of the variables are constant, in this case, pressure and amount or number of moles.